Hello students. So in this exercise 6b, we are going to look at a situation where we need to add and subtract algebraic fractions. So let's begin. Here's the first question I ask you to try, question 1D. As you can see, we have some algebraic fraction minus another. So the general idea behind adding and subtracting fractions is to make the denominator common, right? So in this case, the first term, we have the denominator 3k. Second term, we have the denominator 8k. So to make them common, I can actually make both of them 24k. How do I do that? I multiply 8 to both the numerator and the denominator to the first term, and multiply by 3 to both the numerator and the denominator of the second term. And that's how I get my second line of my solution. So once I have that, the next thing I'm going to do, right, is to expand everything, right? So expanding it out, here the only thing we need to be careful about is that this is a negative 3 multiplying with the brackets that which is the bracket portion, which is the original numerator, right? So negative 3 times 2f gives us negative 6f, negative 3 times negative 5h. So negative times negative, that gives us a positive 15h. The first two terms quite straightforward, just multiply 8 in. So from here, we can continue to simplify by putting the like terms together. So 8f minus 6f gives us 2f. And we have a negative 32h plus 15h gives us negative 17h. The denominator has remained unchanged throughout. It is the common denominator that we obtained, 34k. So do not forget about the denominator. Sometimes in our excitement of trying to solve this type of questions, some students may actually forget to actually write down the denominator. So be wary of that, right? So this is an algebraic fraction. Okay, next question as you try 2f. So in this particular question, what happened? The same idea. We want to make the denominator common. So when we look at the denominator, we have a k squared minus 1 and k minus 1. Now we don't just want to multiply them together because that will give us k cubed. We try not to have the power too high unless we have no choice, right? So in this case, when I look at k squared minus 1, what I really see is k squared minus 1 squared. And that allows me to factorize it into k plus 1 and k minus 1. Okay, and that's what I did. So you can see that on the right side of the slides, the denominator. So once I have it in this form, it's quite obvious now that to make the denominator common, all I need to do is multiply k plus 1 to both the numerator and denominator on the second term. And I'm going to do just that, and then give us the next line, right? So from here, same process again, expand out the numerator, that gives us 3 plus 2k plus 2. Putting them together, give us 2k plus 5. So that will be the numerator. The denominator, we already know. We can put it back into the expanded form. It's just k squared minus 1 squared, which is k squared minus 1. And that gives us a final solution of 2k plus 5 over k squared minus 1. Okay. Next example, this one is a 4a. So over here, another interesting situation, because we have a situation where the denominator over here, we have 2 times a minus b, and on the second term, we have 3 times b minus a. So one of the brackets on the left says a minus b, the bracket on the right says b minus a. How do we make them the same, right? So if you recall in exercise 6a, we had something like this, where when we try to reverse them, a minus b, and if we write it as b minus a, b minus a is really just the negative of a minus b, right? So that works. So what we do here is that I actually flip them around, change the b minus a to a minus b for the denominator on the second term. But by doing so, I actually need to multiply negative 1 to the second term. And that is the reason why in the question it says plus. In the second line of my working, it becomes minus, because what I did was to multiply by negative 1 so that I can switch the b minus a to a minus b. Okay, that's the rule. This one, it might be a challenge to really just for me to explain it to you through a video like this if you are not familiar with such things. So do make an appointment with me and we can actually speak in person. Okay, but either case, once we have that, if you have understood how it works, the next step quite naturally is to have the common denominator, right? So since we already have the a minus b portion set, all we need to do is look at the coefficient 2 and 3, so we can make the coefficient 6, right? So we have 6 times the a minus b. So to do that, the term on the left will be multiplying by 3 in the numerator and denominator. The term on the right will multiply by 2 in the numerator and denominator. So we have 15 minus 8 over 6 times a minus b. That gives us 7 over 6a minus 6b. Okay. Right, next example, question 6b. Once again, we look at this situation, and I don't just want to multiply them together. Don't be too hasty about that. If we can keep the power of the denominator to square, will be good. We don't want to go into cubic, right? So, and we examine it and we realize, yeah, b squared minus 5b minus 6, I can factorize that. So I'm going to do that first, right? So when I factorize that, to get what we see on the first line on the right side of the slides, we notice that, wait, the denominator already have a b minus 6, right? So all I'm lacking is a b plus 1 to the second term. And I'm going to do that, multiply by b plus 1 to the second term in both the numerator and denominator, so that the denominator becomes common. And I will expand that, right? So minus b times b giving minus b squared. Sorry, negative b times b giving negative b squared, and negative b times positive 1, negative b. Okay, and of course, if we want to make things a little bit cleaner, generally we try to write the higher power on the left, so I can rearrange it, right? So becomes negative b squared minus b plus 1 over b squared minus 5b minus 6. But if you have gotten the third line, you are actually successfully simplified this particular question already. Okay. Right. Question 8. Okay, here's the situation now. Here we have some fractions over another fraction. So we have a fraction for a numerator and a fraction for a denominator. Some students may get very distressed when they see this kind of situation. Well, don't panic, right? So we do know that for a fraction, it simply means that the numerator is dividing the denominator. So we can write it in this form, right? The numerator divided by the denominator, so that we do not have a fraction over fraction. So it looks cleaner, right? We don't need to panic. And of course, the next thing we know is that dividing a fraction is the same as multiplying with its reciprocal. So we do that. So divide by 2 over x becomes x over 2. Now, the portion that is inside the first bracket, right, what we can do is, of course, make the denominator common and put them together, right? So we have 3x and then y. We can put them together, so the denominator becomes 3xy. That means I multiply by y on the left side, multiply by 3x on the right side to get y plus 6x. So after that, just multiply accordingly. Here 6x times x. It's 6x squared. There's a mistake in my slide, right? And xy. Oh, there's no mistake in my slide. I'm so sorry. I was going too fast. Right. So what happened is there's actually a copy of x in the denominator. I actually remove it straight away instead of removing in the next step. I was thinking of doing it step by step. But yeah, you can actually check straight away. The numerator, we have x here, denominator is x here, so they actually eliminate each other. And then there's a 2 here. There's no 2 in the numerator, so the 2 got to multiply the denominator. That gives us 6y. So yeah, this solution is correct. I confused myself for a little while because I was thinking too fast ahead. Right. So here we go. Okay. So that's question number 8. And that's the last question I ask you to try for this particular exercise. I hope you're successful. Okay. So all the best, and have a nice day.